Welcome all to Fanshala. So today we are going to start a chapter on statistics called probability, which is basically under the MSc and B.sc geography curriculum. So without wasting any time, let's start with the chapter. But hey yo, hold up. More than 66% of the people watching my content aren't subscribing to my channel. So please do subscribe to get into more educational videos. It's a warning.
कोई तरीका है भीख मांगने का? भीख तो हाथ जोड़ के मांगते, आप लोग तो दादागिरी कर रहे हैं। आप
In our day-to-day life, we come across certain situations where there occurs even chances of a certain situations or an event to take place. Let's explain this from certain examples, like it might or might not rain today. Rajesh may or may not come first in exam. India might or might not win the next World Cup.
मार साले का खोपड़ी तोड़ साले का मेरा
So, all these sentences have one thing in common, and that is uncertainty. Probability is the measure of this uncertainty. It is a branch of mathematics concerning events and numerical descriptions of how likely an event can occur. Now, we must get to know about certain terms. Experiment is an action which results in some well-defined outcomes. Sample space is a collection of all possible outcomes of an experiment. Event is a subset of the sample space associated with a random experiment. For example, when we throw a dice, we can get any number from 1 to 6, so that numbers become our sample space. Favorable outcomes are the outcomes which ensure the occurrence of an event. Okay, now the question arises, why do we need mathematical concept to get incorporated in a geographical environment? That's because probability is a fundamental building blocks of inferential statistics, where this inferential statistics makes confident statements about characteristics of population based on sample information or to test hypotheses. Okay, hold up. Relax for a moment. I know it is becoming quite difficult for you all geographers out there to digest such heavy mathematical terminologies.
अरे बाप रे, ये तो धोती खोल रहा है।
But trust me, we not need to go much deeper into this concept. We need to solve certain problems and gather knowledge regarding certain axioms of probability.
ये बड़ी अच्छी बात कही आप।
Okay, let's take a look on the formulas to find out the probability of an event. The first one, which is the most important one, is the number of favorable outcomes divided by number of possible outcomes. Now, coming to the axioms of probability, the first axiom of probability states that the value of the probability of an event would always be from 1 to 0, which means that value of probability of an event would neither be greater than 1 nor be less than 0. The second one is basically stating that the summation of the probabilities of an event would always be equal to 1. The third one is basically to find out the non-occurrence of an event, which is 1 minus 1 by n, and n here represents the number of events. In the fourth case, we have two kind of things. One is conditional and one is additional. When we need to choose between two probability of an event, then we'll apply the first, and when we need both the probabilities of an event, we'll apply for the second one. Okay, now getting done with the axioms of probability, let's start with a simple sum on probability, stating that a coin is tossed once, find the probability of getting a head and a tail. Now we know in case of a coin, we have two sides, a head and a tail. Okay, so the total number of probable outputs would always be 2. Now this 2 forms the total number of possible outcomes, which forms the denominator. In that case, we'd get one head or one tail. So the probability of getting a head is 1 by 2. Here 1 represents the favorable outcomes and 2 represents the total possible outcomes. The same thing would get applied for the probability of getting a tails, that is 1 by 2. In this sum, we are applying this formula, that is number of favorable outcomes and number of possible outcomes. So having done that, let's come to the second question. It states that Simran buys a fish from a shop for her aquarium. Shopkeeper takes out one fish randomly from the fish tank containing 5 male and 8 female fish. So what is the probability that the fish taken out by the shopkeeper will be A. Male, B. Female? Now, the total number of fishes in the tank is 5 plus 8, that is 13, which forms the total number of possible outcomes. And this is our sample space. So the probability of getting a male fish is 5 by 13, where 13 forms the total number of possible outcomes, and 5, which is the number of male fishes, forms the total number of favorable outcomes. The same thing gets applied for the female fishes, where the probability of getting a female fish is 8 by 13. And the same formula is used in this sum also. Coming to question number 3, which states that a box contains 5 red marbles, 8 white marbles, and 4 green marbles. One marble is taken out at random. Find the probability that the marble taken out is A red, B white, C green, D not green. In that case, when the question states that the marbles are taken out randomly, then it means that each marble has equal probability of being taken out. For that, total number of marbles present in the box are 5 plus 8 plus 4, that is 17, which becomes the total number of possible outcomes, which is our denominator for the formula. So, in A, the probability of getting a red marble is 5 by 17, where 5 becomes the total number of favorable outcomes because there are 5 red marbles present in the box. In case of B, probability of getting a white marble is 8 by 17 because there are 8 white marbles present in the box. In that case, 8 becomes the total number of favorable outcomes. The same things get applied for the C in case of a green marble. But in case of the D, probability of not getting a green marble, we have to apply the axiom where there is non-occurrence of an event. That is 1 minus 1 by n. So it is 1 minus 4 by 17, which makes it 13 by 17. I hope you all are understanding and can track down the axioms of the probability being applied for each and every sum. Till now, we were practicing all the sums on the basis of simple events or single drawing event. Now, we would shift to the examples where we will be performing multiple drawing events for each of the probability sums. Now, suppose a bag contains 4 white and 10 yellow balls. Two balls are drawn at random. What is the probability that one would be white and the other one would be yellow one? Seems quite difficult, right? This one we would be solving with the help of a scientific calculator by using the NCR key in the calculator. For the favorable outcomes of the white balls, we will type 4C1, and for the yellow, we will type 10C1 in the calculator, which forms the numerator section. And for the total number of outcomes, we will write 14C2 in the denominator section. These are the steps which you need to follow. Now, for the formula for calculations, it is 4C1 into 10C1 divided by 14C2. The numerator section representing the favorable outcomes and the denominator section representing the total possible outcomes. In the format of 4C1, let me clarify. 4 represents the total outcomes and 1 represents the possible outcomes for the white balls. And in 10C1, the 10 represents the total outcomes and 1 represents the possible outcomes. Placing them in formula, we would get 40 divided by 91, which makes it 0.43. For the next sum, we have an urn contains 10 balls, out of which 3 are white, 4 are blue, 3 are black. Now 3 balls are drawn randomly from the urn so that all balls get equal probability of getting drawn out. What is the chance of getting 3 balls of all different colors? Now in this case, for white balls, the favorable possible outcomes would be 3C1. For blue balls, the favorable possible outcomes would be 4C1. And for the black balls, the favorable possible outcomes would be 3C1. Now this 3, 4 and 3 for the White, blue and black balls are the number of balls which are present in the urn. And these three ones which are written after the C represents the number of balls which can be drawn out after one take randomly. And the total number of possible outcomes would be 10C3 because 10 represents total number of balls that are present in the urn. Placing them in formula, we get 3C1 into 4C1 into 3C1 divided by 10C3, which makes it 36 divided by 120, which makes it 0.3. In this sum, a bag contains 5 white balls, 6 red and 9 green balls. A ball is drawn at random from the bag. Find the probability of finding the following: A. A green ball. B. White or red ball. C. Neither a green nor a white ball. In this case, the total number of balls in this bag are 5 plus 6 plus 9, that is 20, which is the sample space or the total number of possible outcomes. So number A, the probability of getting a green ball is 9 by 20 because there are 9 total green balls in the bag. For B, the probability of getting either a red or a white ball, which is total number of red and white balls, is 5 plus 6, that is 11. So probability of getting either a red or a white ball is 11 by 20. For number C, the probability of getting neither a green nor a red ball, that is total number of balls which are neither green nor white, are the red balls, which is 6. Probability of getting neither green or red ball, which becomes 6 by 20, which is 3 by 10. So we have done certain basics of the probability which comes for the examination, and now we are going to be discussing the favorite ones of the university, that is dice, coins and cards. So the dice, which we have seen since our very childhood in the games like Ludo, and also we have seen it in movies how the heroes throw them in full swag while playing in the casinos. Now we all know that each dice has 6 sides with numbers 1 to 6 printed on it. So that makes there 3 even numbers and 3 odd numbers in a dice. Hence, in the case of dice, the total possible outcomes for a single dice is 6. If asked for the probability of getting an even number, it would be 3 by 6, that is 1 by 2. And same goes for the odd numbers as well. If you are asked that 2 dice are rolled simultaneously, in that case, the sample space becomes 6 into 6, that is 36. In that case, if you are asked to find the probability of getting an even number if 2 dice are rolled together, then the appropriate combinations of the total possible outcomes would be 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, 6, 2, 6, 4, and 6, 6. Then the probability for getting an even number would be 9 by 36, which makes it 1 by 4. And to find the probability of getting a prime number, for example, the appropriate number combinations would be 2, 2, 2, 3, 2, 5, 3, 2, 3, 3, 3, 5, 5, 2, 5, 3, and 5, 5. So the probability of getting a prime number when 2 dice are rolled simultaneously would be 9 by 36, that is 1 by 4. Now coming to my favorite part, which is the cards. Now this is a normal deck of cards which consists of 4 suits. One is the black, which consists of club and spade, and the other color is red, which consists of heart and the diamond. Each of the suits have 13 cards in it, which makes it a total of 52 cards in a deck, where there are 4 aces, 36 number cards, and 12 face cards. Now the question states, A card is drawn from a well-shuffled pack of cards. Find the probability of finding an ace, a red card, neither a king nor a queen, face card, card of spade or an ace, non-face red colored card. Now for the reference, I am showing you the deck of cards here. Now for A, the total number of possible outcomes is 52, which is the total number of cards present in the deck, and total number of aces is 4. So the probability of getting an ace is 4 by 52, that is 1 by 13. Number B, probability of finding a red card. In this case, the total number of possible outcomes remains to be 52, and total number of red card is 26, consisting of the diamonds and the hearts. So probability of getting a red card is 26 by 52, making it 1 by 2. Third, neither a king nor a queen. Total number of possible outcomes still remains to be 52. There are in total 4 kings and 4 queens. Hence total number of kings and queens are 8. So the number of cards except king and queen are 52 minus 8, which makes it 44. So probability of getting neither a king nor a queen is 44 by 52, that is 11 by 13. Number 4, getting a face card. Total number of possible outcomes is 52 and total number of face card is 12 in the deck of cards. So probability of getting a face card is 12 by 52, making it 3 by 13. For the next, we get card of spade or an ace. Total number of possible outcomes remains to be 52. Total number of spade is 13 and total number of aces is 3. Now some students may complain that we can clearly see there are 4 aces. Why have you written 3? Because one ace of spade we have considered for the number of spade card, that is 13. Total number of spade and aces becomes 16, and hence probability of getting an ace or a spade becomes 16 by 52, which is 4 by 13. And for the last one, non-face red colored card. In here, total number of possible outcomes remains to be 52. There are 26 red colored cards, out of which 6 are face cards. Hence, non-face red cards are 26 minus 6, which is 20. Therefore, probability of getting a non-face red colored card is 20 by 52, making it 5 by 13. Now, there is a certain category of sums in which the cards get removed and are not replaced. In this case, if it says that after removing the red cards, what is the probability of getting a king? So after removal of the red cards from the deck, it will consist of 26 remaining cards, which is 13 spade and 13 club. So number of kings left are 2, 1 from the spade and 1 from the club. So probability of getting a king would be 2 by 26, which is 1 by 13. Now in case of the sums in which the coins are tossed, if the sum says that 2 coins are tossed at the same time, what is the probability of getting at least one head, at least 2 tails, and at most one head? So in case of tossing 2 coins at the same time, the sample space becomes head head, tails tails, tails head, and head tails. So for number A, for getting at least one head, the probability is 3 by 4. For getting at least 2 tails, the probability is 1 by 4. And getting at most one head, the probability is 2 by 4, making it 1 by 2. This 3, 1 and 1 from the numerator sections, we can figure it out from the sample space where we get 2 head, 2 tails, 1 head and 1 tail, and 1 tail and 1 head. That's it for today's video. I hope you all have understood how to calculate and solve the problems related to probability, its axioms, and in which situations this probability gets applied. Hope to see you guys in the next video very soon. Till then, like, share and comment and subscribe to my channel for more educational videos. Always remember, it's Fun Shala from us to you.
हमारे पास है भैया 3 बादशाह।
क्या? दिखाओ दिखाओ 3 बादशाह।
एक बादशाह,
हाँ।
दूसरा बादशाह।
तीसरा तीसरा बादशाह दिखाओ।
मेरे ताश के 53वें पत्ते। तीसरे बादशाह हम हैं। दिखाई नहीं देता? तीसरे बादशाह हम हैं।